Okay, chapter 19, day 1. What we're going to focus on is how do we find a confidence interval for the difference of two proportions. So in the past we've taken a confidence interval for a proportion, or even also for a mean, but now we have two proportions and we want a confidence interval for how much different they are from each other. So in order to accomplish this task, we have to have, again, some common vocabulary. So we're going to call P1 hat the proportion that we get from sample 1. So you take x divided by n for sample 1, and you're going to get a P1 hat. P2 hat is the proportion that we get from sample 2. And again, z star is still that critical value from the formula sheet. And again, it's usually like 1.960, 1.645, 2.576. It's that value we have, and again, it's on our formula sheet. The formula that we're going to use is pretty standard in the sense that we have some different parts. The first part we have is what we're trying to estimate. And we're trying to estimate a difference in the two proportions. So we take our proportions from our data and we're going to subtract them. Plus minus this z star value times standard error. And the standard error here is the combination of the two separate standard errors. And there's some slight modifications to that formula. You don't have to worry about where the formula came from. We just have to be able to apply and put the numbers in. So again, here's P1 hat, and N1, sample size for group 1, P2 hat, and sample size for group 2. Fill in all the information. You're not going to calculate it. The calculator will do all the calculation for us. So on the calculator, you are going to type in stat test B, which is a two proportion z interval. So on the calculator, it's going to ask you for N1 and X1. So X1 is the number of successes in sample 1. N1 is your sample size for sample 1. X2 and N2. And again, it's going to ask you for the confidence level. And you just put in that number written as a decimal, like 0.90, 0.95, 0.99, depending on what confidence level you want. And you hit enter. And it's going to give you an output. It's going to give you a set of parentheses. But what's different now is that the parentheses that you get will take on three different options. Both numbers might be positive. And if both numbers are positive, then the interval is an interval in which the first population is higher than population 2. Because you're subtracting two numbers. If I take two numbers, A minus B, the only way I get positive answers is if the first population, population A, is higher. So both positives in our interval tells us that whoever the first group is from this number to this number percent higher than the other group. So these are going to be decimals. You're going to move the decimal place twice, convert them to fraction, or convert them to percents. And so you'd say group A is this percent to this percent higher than group B. If they're both negative, the only time that happens is if group B is higher, group 2. So you say group population 2, whoever or whatever that is, and this one you're going to read in reverse because the way that negatives are, the smaller negative is actually here. So you'd say from this percent to this percent higher than the first group. Now, if there's a negative and a positive, there's a variety of things that you could say. But what we're going to say is just purely, since 0 is in my interval. What do I mean by that? Well, if I said it goes from like -2 to +5, well, anything that spans from negatives to positive always includes the number 0. And since 0 is in my interval, it would suggest no difference between population 1 and 2. Again, if I took two numbers and subtracted them and I got 0, that's only possible if they're equal. Since 0 is in an interval that spans from negative numbers to positive numbers, it would suggest no difference between population 1 and 2. So let's take a look at an example. So here's an example. We want to know if there's a difference in the proportion of students that wear glasses based on their eye color. Random sample of students revealed 38 out of 249 brown-eyed students and 16 out of 97 green-eyed students needed glasses, created 99% confidence interval. So, we're going to let population 1 be brown and population 2 be green. And so for the brown-eyed students, X is 38 out of 249. So there's N1, X1 and N1. And 16 out of 97 for the green-eyed students. So if I took 38 and divided by 249, I'd get P1 hat. 16 divided by 97, I get P2 hat. Now, 99% from the formula chart comes out to be a 2.576 Z-star number. So I'm going to fill in my formula. So P1 hat minus P2 hat, I just put all of these numbers into my formula, and I go to my calculator. So stat, oh, it's thinking I have a pen. Pardon me. Get rid of this stuff. We're going to go to test, and then we're going to go to option B. So, two proportion Z interval. So X1 is 38 out of 249. So X1 is 38, 249, 16, 97. Confidence level is 0.99 in calculating. And notice, it gives me my answer. Negative 0.12 up to positive 0.10. Negative 0.12 up to positive 0.10. By the way, the calculator output gives you your P1 hat and your P2 hat that you can then turn and put into your formula. But what does it tell us? We span negatives to positives. So if we're spanning negatives to positives, we would say we are 99% confident that since 0 is in my interval, there's no difference between brown-eyed and green-eyed students that need glasses. Now, if they were both negative, we would say whoever group 2 is, and group 2 is green eyes, that 10 to 12% more green-eyed students need glasses than brown eyes. If they were both positive, we would say that we are 99% confident that 10 to 12% more brown-eyed students need glasses. But because we're negative and a positive, it would suggest no difference since 0 is in my interval. And that's two proportion Z interval.